Hey everyone, welcome to another video lesson. And in this video lesson, you will learn how to apply quadratic equations to real-world situations. Okay, so let's start with example number one. So for example number one, notice that we're just given words, and we need to make sense out of these words and apply quadratic equations to the problem. So it says you're standing on the baseline of a tennis court and you want to practice your soccer skills. You want to kick the soccer ball from one baseline to the other, which is 78 feet away. But at the same time, only clear the 3-foot net by 1 foot. The ball will travel in a parabolic path. So this gives you a hint. Okay, it's parabolic path. So it's going to behave like a parabola, which is the graph of a quadratic function, with the highest point being 1 foot above the net. Okay, so then first step is we're going to sketch a diagram. So let's say this is the baseline here. Okay, and this is where the ball is located before we kick the ball, right? So we know that this is where it's right on the baseline, so there is no up or down. So meaning the x value is 0 and the y value is 0. X represents the feet the ball travels and y represents the height. So then from here, we want to kick the ball, and we are given that the ball travels 78 feet. So then this is where x is 78 and y is 0 again, because it's back on the baseline. So then it's going to follow a parabolic path. Okay, so I pause the video so I don't take too long on this. So this is 3, but clears the net. So let's say this is the net, right? That's the net, and this is 3 feet high, right? So it's got to clear the net by 1 foot more, which means the y coordinate is going to be 4. And the x, you're going from 0 to 78, just divide 78 by 2, and 78 divided by 2 is 39, okay? So then the coordinates of this point is 39 comma 4, which is the vertex point. So then the way I got that, in case you didn't understand, you take 78 and divide that by 2, and that is equal to 39, which is how I got this value. And this one here says got to clear the 3-foot net by 1 foot. So 1 more than 3, which is 4. So that's why we got 4 as the y value. And for the next part, we're being asked to describe a reasonable domain and range using set notation. Okay, so let's see. Let's do domain and range. So this is asking for set notation, so that means the curly brackets. Okay, and we know x domain is x values, x such that, and range is y values, so y such that. So now watch this. It says describe a reasonable domain. So notice that for the domain, this is going from 0 to 78. So there is no infinity implied here. Okay, so that means I'm just going to go 2 units more, or 2 feet more than 78. So 0, which is this point here, less than or equal to x, because it's a domain, which is less than or equal to 80. So again, that will be a reasonable domain for this problem. The range goes from 0 to 4, so I'm just going to make it, you can make it 5 or 6. So then this is 0 less than or equal to y, which is less than or equal to 6. So what this is going to do is, you're going to set this on this will be the window setting on the calculator. Okay, window on calc. All right. So then for the next part is, it says, write an equation in vertex form relating the height of the ball to the distance traveled. So this is review from the first semester, and also you saw this on the video lesson for 10.1. Okay, so for this one, I'm going to use this formula, which is a vertex form, quadratic, y equals a times x minus h squared plus k. Then I know the vertex point is this one here. So this is the vertex point. So the vertex has coordinates of 39, 4. Then I can choose one of the points. I can choose either this one or this one. So I'm going to choose the easiest one. So the point that we're going to use is 0, comma 0. Now don't forget, this is h, this is k, this is x, and this is y. Then I'm going to plug in or substitute for h, k, x, and y into this equation. Okay, so then instead of y, I plug in a 0, and instead of x, this will be 0, and instead of k, instead of h, 39, and then instead of k, 4. So I just substituted for these values into this equation. Then it starts simplifying. So then 0 equals a times negative 39 squared plus 4. When you take the square of 39, that is equal to 152. Let me just check this real quick, okay? Because that's a large number. I'm not going to do this by hand. Negative 39 squared, that's 1521. So 1521 times a plus 4. Then I'm going to, as you know, jump this 4 to the other side. So then becomes negative 4 equals 1521 times a. Then I'm going to divide by 1521 on both sides of the equation. Okay, which means a equals negative, and I don't know if this simplifies. No, it doesn't simplify. So then negative 4 over 1521. So once we know the value of a, we can write the equation because we know the vertex. So then the equation for this problem is y equals, let's see, a is negative 4 over 1521, open parentheses, x minus h, so x minus 39, take the square and not the k value, which is 4. And you can check this on a calculator, by the way, if you want, okay? So then this is what the problem looks like. So let me just show it to you graphically. So I'm going to go to y equals and enter this function. All right, so then let's see, negative 4 over 1521, and then in parentheses, x minus 39, take the square of that, and then add 4. Then I'm going to press window. On the window setting, I'm going to use this domain and range. So the minimum is 0, and the maximum for range domain is 80, and then for the range, the minimum is 0, and for the max is 6. Okay, so when I graph it on the calculator, I should be able to see something similar to this. So let's press graph. Oh, and I think I might have made a mistake here. Let me go back and check this. No, it should be fine. I don't know why it's not showing up. I'll check the window settings. Okay, this is where I messed up. The y minimum is 0, and the maximum, let's make it 6. Then graph, let's see. Oh, there it is. Okay, so now we can see the graph, and it looks just like what we created here. All right, so let's move on to the next question. The next question is the vertex a max or min? Well, obviously that's the highest point, so it's a no-brainer. It's the maximum. List the transformations in regard to the parent function. So first it's got a negative, so that negative creates a reflection over the x-axis, and then this 4 over 1521, that's less than 1 and more than 0. So then that creates a vertical shrink by 4 over 1521. And then the minus 39 makes the graph go to the right 39 feet. And then the plus 4 shifts the graph up 4 feet, okay, off the ground. So those are the transformations.